Alright, hit the button, but I don't think anybody is actually here. Okay. Alright, I still have it on the screen here, so... I should probably type in the chat here. So, we're back online. How many people are in the stream? 2. I have no idea how many people I had before, so... Okay, people are coming back in, it looks like, so... Hi, everybody. Sorry about that. Everything seems to be working now, so I was able to get my pen working. My computer reboots really quickly. It's just setting up the stream and everything is very, very slow. So I had to take the stream down, and then I had to put in all the captions and stuff because otherwise I have to go back and do it later. And it's already right there, so I might as well just type it in, so I did. And then rebooting takes like 20 seconds because I have a solid state drive on this PC. And then it's more just waiting for YouTube to connect. Okay, so I'm back up to 8 now. Okay, well, hopefully people will start coming back in because we need to get started here. All right, but what I do have is, so I have this back on the screen here. All right, and if I try to write the word empirical, it totally works now, so that's good. Now, if I wanted to figure out the empirical mass, then I need to type this into Lentech, and so let's go get Lentech out. I don't actually have it open. I can't spell Lentech, apparently. Alright, what is this? This is C5H7N. Alright, so it says the empirical mass of our compound is... I always start talking and I forget the number. 81.12. 81.12. Grams per mole. Okay, cool. What's the molecular mass, then? Uh-oh, they don't give us that. They give us some weird craziness, right? But what we do know is that for the molecular compound, 40.57 grams would be this many moles, right? And so if I just do this division, I can actually get the molar mass in grams per mole, which ends up being this. And wouldn't you know it, this and this are off by a factor of 2, because if I take 162.3 divided by 81.12, these are both grams per mole, but that's going to cancel out in a second here anyway. You get 2. So I'm going to just take my formula up from here. I'm going to times it by 2. And there's nicotine. Alright, so that's how you do that. And now I need to give you the problem to try, which I had hoped that we would have gotten to like 20 minutes ago, but technical difficulties abound, and also discussions about chlorine gas and TNT and all sorts of stuff. So I'm going to give you butane dione. This is butane dione's elemental analysis. If you decompose the sample I give you, it gives you 27.9 grams of carbon, 3.512 grams of hydrogen, and 18.59 grams of oxygen. So first find the empirical formula. And then, once you have found the empirical formula, knowing that the molecular weight of the compound is 86.09, find the actual molecular formula. I'm going to give you about 5-6 minutes to do that. Then we'll go into concentration. See you in a bit. How we doing? Once you have the answer, type it in the chat. I see somebody's already got a result. We'll go over the answers about 2 or 3 more minutes. All right, let's go over the answer here. So I got to go over here to do that. All right, so let's do this part first. Got to clear this guy. And all right, so we're going to turn everything into moles. So we've done this enough times that this should be trivial by now, at least this first part. Typing it in your calculator, on the other hand, not as easy. All right, so there's my moles of carbon. I'm going to do grams of hydrogen and moles of hydrogen. And that's 3.484. This is supposed to be grams of oxygen. I kept writing hydrogen for some reason. What is this? 15.999? Disconnected. The stream might jump a little bit there. I think it should be back now. So the stream might have hiccuped there because apparently when it rains at technical difficulties, it pours technical difficulties. Let me know if I'm back. Let me know if everything is okay anyway. We're going to make the pseudo formula, which is C2.323, H3.484, O1.162. I'm going to divide by the smallest number. Yeah, that happens on very rare occasion. I lose a connection to YouTube. My internet's really good. Like, it's not fast, but it's really remarkably stable. Because I have fiber. I'm not on cable or anything. All right, so there's our empirical formula. But that does on occasion happen. Like, no surface is perfect, yeah? All right, so there's the empirical formula. And then I got to cover that up for just a second here. If the molecular weight is 86.09, what is the molecular formula? So let's find the empirical mass now. And we'll get that by typing it into Lentech. So C2H30, or O, not 0, 43.04. I can remember that. All right, and so the molecular mass over the empirical mass would be 86.09. Remember, AMU and the grams per mole are the same thing. And you get a multiplier of, I was going to write times 2, but I could really just write 2. I mean, if I hadn't gone straight through the 2 there, that would have been okay. There you go. There is our molecular formula. All right. The chemistry is good, but the technology's not. All right. We already had sort of a break, but I also need a break because I need to use the restroom. So I'm going to put this up here real quick. But instead of 10 minutes, we're going to just do 5 minutes because I'm not going to take that long. So let me edit this to boop. There we go. And I'll just start the timer. Let me go quickly click on something in the music. Yeah, there we go. That's fine. And I'll be right back. There we go. Everything seems to be better now. I hope. I guess we'll see, right? Alright. First, before I leave this screen, I do have to change this back to 10, because I will forget. Boop. Boop. Oops, that's the wrong card. There we go. Alright. We gotta talk about molarity. Now, we don't have to finish this section today, thankfully, because I can't believe that I'm actually ahead on our lectures so far. Like, I feel like we were behind at one point, and now I look at the calendar and I'm like, wow, we're really ahead. So we're going to do as much of this as we can, and then we'll finish up the remainder of it on Monday. Because next week is an exam week, so the schedule changes, and I do want to talk about that at the end of the class today. So, in order to understand molarity, we need to talk about what a solution is. A solution is any homogeneous mixture containing a solvent and a solute, or maybe even multiple solutes if you so choose. When we do chemistry in Gen Chem, all of our solutions are going to be aqueous solutions. We're going to use water. But in other classes, such as organic, you might have solutions where the solvent is ethanol or something like that. Now, what are these components that I'm talking about? So the solute, oops, that's okay. The solute of a solution is whichever substance you have less of, and the solvent is whichever substance you have more of. So if I had, like, say, salt water, and I were pouring, like, a teaspoon of salt into a cup of water, I have way more water than salt, so the water's the solvent. In the ocean, there's way more water than any other thing that's in there, so the water's the solvent, and the things that are dissolved in the ocean water are the solute. To make any solution, you mix the solute into the solvent. Easy enough. Now, in all these pictures here, on the side here, in my very low-res picture that I found, all of the various food colorings and dyes would be solutes. Or if I had a substance that itself had a color to it. So, for example, copper compounds tend to be very blue in water. The blue comes from the copper itself, so the copper is the solute. Now, depending on how much stuff you have in your solution, we're going to assign it a term. We're going to call it either concentrated or dilute. Now, these are relative states to one another. Something cannot just be concentrated by itself, unless you're using it in some sort of colloquial way to say this is as highly concentrated as it can get. So, for instance, if we buy concentrated HCl from a vendor for the laboratory, we're getting 14 molar HCl because that's as concentrated as it gets. But if I just give you a solution of 1 molar HCl in the laboratory, I can't describe it as concentrated or dilute unless we actually do something to it. So these are descriptors, but they are relative descriptors. Now, if you have a concentrated solution and you add water to it, then what ends up happening is that the space between the solute particles, and so that's what these are, actually, just in case this wasn't clear. So these are solute. The water is the interstitial space. In this diagram. So if you add water, you are basically spacing the particles out more and you are diluting it. Now, concentration, remember, is number of particles per volume. So you can see that if this is my volume, wow, I was doing great on that square until the very end there, wasn't I? If these are my volumes, you can see that on the left square there are more solute particles, so it's more concentrated. Adding more water would just mean that half of the particles get pushed out with the other half of the water that I've added. And so the solution ends up being dilute. There's the same number of particles, but these extra particles that... Oh, okay. I thought I lost my cursor again. I was about to be real upset. These extra particles, maybe like up here, got shoved upward, so now they'd be up here. So they'd be in a larger volume. And we just play with this. So if the number of particles is the same, but the volume increases, then the concentration would go down. Likewise, if the number of particles decreases for a given volume, concentration also goes down. So the act of dilution is doing one of those things. Now, I gave you the formula on the previous page, number of particles per volume, so let's just formalize it here. Note that the bottom of the expression is not liters of solvent, it is liters of solution. So you want to know the entire solution. That means that the solute, which is oftentimes a solid, when you add it to your liquid, it may not seem like it changes the volume, but it totally does, because solutes have volume too. It's just that they don't take up that much volume relative to the liquid, so it becomes very easy to think, oh, okay, yeah, my solute doesn't do anything to the volume, but it does. So you need both in there before you can calculate the volume and do the calculation. So as a real simple example here, what is the molarity of a solution formed when 2 moles of calcium chloride are mixed with 1.75 with enough water to make 1.75 liters of solution? Notice I was very careful with how I said that. I didn't say mixed with some amount of water. I said mixed with enough water to form this much solution. I just read it wrong. So let me get this back on the screen. Boop. Oh, wow, that worked out okay. All right, so molarity is moles of solute over liters of solution. And so the number of moles of solute was 2.00. And the volume of the solution was 1.75 liters. And when I do that, I think I get 1.14, but I'll punch it in the calculator anyway. Yeah. For molarity, the units don't cancel. However, since we write molarity so often, there is an abbreviation for it. And so if you see capital M as the unit, that means moles per liter. So that is a unit that we're going to be running into all the time. That's the wrong thing. There we go. It looks just like that. Now, that's how you do the calculation for this. What would this look like in terms of a picture? Like if I had to show you the process going on. Oh, I thought I had a picture of it. Oh, it's coming up. Okay. All right. So now that we know the formula for molarity, we can use it in calculations. Because it turns out that if you take molarity and multiply by volume, like I showed you in the pre-lab bit before, you get moles, and this is why. Here are the units of molarity. Here are the units of volume. Dun dun. There you go. Now, if you know the number of moles of something, then you could figure out the number of grams of that something, or so on and so forth. You can do any calculation that we did at the end of Chapter 2 once you know the number of moles of something. Let's suppose that you needed 300 milliliters of this 2.80 molar solution to do an experiment. How many grams of salt are in that? Well, let's find out. All right, so remember that MV equals moles. And so if I multiply my molarity and my volume together, that would tell me the number of moles of NaCl. I'm trying to make this decimal point look a little more obvious. There we go. And of course, I draw over the decimal. There we go. Okay. And if I have this many moles, how do I get grams out of it? Well, I just do this, right? I could turn grams into moles into grams. I just need the molar mass of sodium chloride, which I have memorized because I love table salt. That actually has nothing to do with it. I just have done this calculation too many times before, and I get this. So in 0.3 liters of a 2.8 molar solution, there would be 49 grams of sodium chloride, which is a lot. 2.80 moles per liter of sodium chloride is very, very, very concentrated. All right. So now what I want you to do is try answering these questions using these quantities based on the definition of molarity and also the fact that molarity times volume equals moles. So for the first one, what's the molarity of this solution? Here's its volume, and then here's how much potassium nitrate it has. Question number 2, how much HCl is contained in half a liter of 14 molar concentrated HCl? And then finally, what volume of vinegar contains this many grams of solute? That one you're going to have to solve for volume instead. So manipulate the molarity formula around and see if you can get that. We'll go over the answers together in just a little bit. How are you doing? Once you get the answer, type it in the chat. One or two more minutes, we'll go over the answers. All right, let's go over the answers here. So for this first problem, what's the molarity of a 225 milliliter solution containing this many moles, or this many grams of potassium nitrate? Okay, so I need the formula for molarity. I heard Maya meowing, and then she just completely vanished, so... All right, so we know the volume. It's 225 milliliters, but we're going to need to turn that into liters, because that's what it says here. To get the moles of solute, I'm going to need to have this number. I turn that into moles, so let's do that first. So grams KNO3. So those will cancel. And I got to go to Lentech to look that up. That's not how you do that. There we go. KNO3. I'm goofing up the shift key. 101.10. So I got 0. Oh, don't do this again. Don't do. Okay, good. For some reason, it wasn't working. 0.3557 moles of KNO3. So that's the number of moles of solute right here. And the liters of solution is just that number that's on the screen there, 225 milliliters, but turned into liters. So I'm going to write it like this. So 0.3557 moles KNO3 divided by that volume in liters, which would be this. Oops, not 255, 225 liters. And so the molarity I get for that first problem is 1.581 moles KNO3 per liter. All right, that's the first one. For the second one, what mass of HCl is in this container with this molarity in this volume? So remember that MV equals moles. So that would be 14 moles of HCl per liter times half a liter. So that would be what? 7 moles HCl. And we'll just turn that into a mass. And I believe it's that. And I get 255 grams HCl. How do you spell Lentech? I can get you the link right here. Lentech. There we go. I need to quickly step away from the computer. I have an issue that just cropped up. Today is just issues, the stream, so I'll be right back. Oh, I'm so sorry about that. Okay, I'm back. So let's do the last problem here. Oops, I could scroll the thing there. There we go. What volume of 0.8214 molar vinegar contains 19.60 grams of solute? All right, so in this case, we got to solve for volume. And you could use either of the formulas that you want, really. So if you have MV equals moles here, and I want to solve for volume, and volume's this right here, well, volume must just be moles divided by molarity. Okay. Well, if I know how many grams of vinegar I have, that formula right there, by the way, is acetic acid or vinegar. And I don't know what the molar mass is off the top of my head. That's not the Lentech bar. That's my search engine. HC2H3O2. Ah. This is 60.06, 60.05. Probably won't matter that much, but that's okay. So this would give me the number of moles. I got 0.3264 moles of vinegar. Okay, that number goes right here. And you know the molarity. So let's just write this formula out. All right, so we got the number of moles of vinegar, then we divide by the molarity of the solution. Now, looking at it like this, the units don't really make much sense, right? So what I'm going to propose is that we do it this way. And then what I'm going to do is I'm going to change capital M into moles per liter, which is on the bottom of a fraction, so I can write it like this instead. Right? And now it's like, oh yeah, that totally makes sense as written. So if I divide these two numbers, I will get the volume of vinegar that has that much in it. There you go. Oh, does Wolfram Alpha have molar masses? I don't think I knew that. That's cool. I'm just so used to Lentech, probably because I used it before I started using Wolfram Alpha. All right. There's our molarity problems here. So now that you have played around with that a little bit, you have some functional experience with how to work with molarity and what the units are and what they mean. We haven't learned how to dilute anything or do a titration yet, unfortunately. Which, let's see here. We don't actually really need that to talk about the lab, I guess. So let's go back to talking about the lab then real quick. Where I had this window. Unfortunately, I scrolled all the way back to the top because I had to reload all the pages here. And so you can see in our diagram here of the burette and the flask there, you're going to have some substance being poured into some other substance. One of them is known. In this case, it's the base. So you have the base of known concentration, so you know its molarity. And you know how much volume you would use to do the titration. So if you know molarity times volume, you know number of moles. Down here in the acid, you know the volume that you put in here, but you don't know the number of moles. So if you can figure out the number of moles in here and the volume, you could figure out its molarity. And so the way that you do that is you figure out the number of moles in the base that you use. So for example, here's a calculation. If I use this many milliliters and this is my concentration, there would be this many moles in the solution. I actually don't know why there's a 0 missing there. There should be another 0. Then down here, if I take the moles of sodium hydroxide, remember we said that, 1 mole of sodium hydroxide reacts with a mole of HCl. So this number just becomes this number. And then you can figure out the concentration of the unknown. Now, I also have another video for this one that you can watch the instructor do a titration. The titration video is not as good, unfortunately. It's hard to find good videos that match what exactly I want to show you. But for the titration part of the experiment, you're going to get a chart that looks like this. I did the titration, and I started with this volume in the burette. I ended with this volume. So you should know what volume I used. You know what the concentration is because I wrote it up here for the sodium hydroxide. So now you know the number of moles. If you know the number of moles of sodium hydroxide, you know the number of moles of HCl. You know the volume, you can get the molarity. That's part B. That's the gist of how titration works, is you know both components of one substance, the molarity and the volume, but you don't know the components of the other one. And so you solve it based on how the chemistry works. And so for this specific reaction, this is the reaction that you're doing right here. HCl and NaOH makes salt water it just makes salt water. Okay? So that should be pretty much all you need to know for this lab. Make sure that you are filling out your data tables with sigfigs correctly. Answer all the questions thoroughly. I'm still in the middle of grading stuff for this class, and I noticed that really one of the major issues that comes up in any class, regardless of whether it's 121, 140, or 161, is you get a question and I get an answer that's along the lines of the most vague thing I can think of. So if I ask you, like, what made you come to this conclusion? And then a student response might be, well, I followed the procedure. And I'm like, yeah, duh. I hope so, right? But so whenever you're answering questions in the laboratory worksheets, make sure that you are answering them in detail. If I ask you, why did you come to this conclusion? Tell me your thought process that led to that. Say, okay, I'm titrating. This is the molarity I got. So that's how many moles of acid there are. I divided by this. This is the result that I got. That answer makes sense because it should be about the same as whatever I started with, etc. Okay? So try and back up what you're describing with not only just like how you walked through the experiment, so don't just rehash the procedure, but also like what it means and what the numbers mean, and try and do the best that you can with that. All right. I think that that's all that we're going to have time for today, because the last little bit I do want to talk about next week, what's happening. So we're going to return to making solutions on Monday, because let me get a calendar up here really quickly. So, oh, you know what I should just get? We'll just grab the syllabus real fast. So next week is exam week. And what that means is that on exam week, I have a review session, and the review session is going to be on Wednesday. So instead, for our lecture being on Tuesday and Wednesday next week, it's instead going to look like this. So here's our syllabus. So we're right here currently. We didn't finish the chapter, but that's okay. We're actually pretty ahead. We're going to finish it on Monday, and then I can do everything I need to for chapter 3 in the rest of Monday, and then also on Tuesday. And if I absolutely had to, I could do it on Wednesday. So our next lecture is actually going to be on Monday. Normally we don't have class on Monday, but this coming Monday we will. So week 5 Monday, we will have a Monday lecture. We'll have a Tuesday lecture also, and then Wednesday is just a review session, which is optional. I will not bring questions specifically to the review session, but if you have questions you'd like to go over, whether they're from the OpenStack text or anything like that, let me know. Keep in mind the lab is due the day before, so please don't bring lab questions to the review session. That's not the point. It's to review for the exam, because your exam number 1 will be on Friday. You'll have all day to do it. Friday the 7th. Alright, so as long as we're all aware that there's a lecture on Monday, and of course, if you don't show up to it, that's fine. You can always watch the video later. Okay, I think that's all I have. So we'll call it a day here. Thanks for coming out to the lecture. I apologize for all the technical snafus. I did not expect my tablet to die and have to reboot the computer. At least the tablet still works. Little victories, huh? There we go. The program that I used to play my little outro music broke. Everything is falling apart. At least this works, though. Alright. See you next week. Have a good weekend.